Breaking news. At 0411 UTC today, automated alert systems across the globe triggered simultaneously. Data streams from space-based observatories and ground stations began flashing red within seconds. At observatories in California, Germany, and northern Chile, scientists watched the same impossible pattern unfold in real time. Today, the impossible just happened. Moments ago, the interstellar object known as 3I Atlas experienced a sudden, violent energy release precisely at Perihelion, the point of its closest approach to the Sun. But this was no ordinary outburst, no cometary jet, no thermal cracking. What unfolded defied every predictive model we have. An object that should have remained stable instead erupted. This changes everything we thought we knew. If you want real-time updates on the most mysterious cosmic events ever recorded, make sure to like, subscribe, and stay with us, because what you're about to hear is not speculation. It is data, and it is unprecedented. The confirmation came swiftly and decisively. NASA's Deep Space Network was the first to register the anomaly, a sharp spike in broadband electromagnetic noise, followed by a sudden drop in reflected radar cross-section. Within minutes, ESA's European Space Network confirmed a coincident disruption in telemetry returns. Almost simultaneously, optical observatories in Chile reported a sudden bloom of light around 3I Atlas, bright, brief, and violently asymmetric. At the Atacama Large Millimeter Array, technicians halted routine observations and pivoted all dishes toward the target. In Maryland, mission analysts at NASA received a priority data packet flagged with the highest anomaly classification. In Paris and Darmstadt, emergency coordination calls were initiated before sunrise. This was not a single sensor glitch. This was convergence. The James Webb Space Telescope, operating in infrared wavelengths between 1 and 10 microns, was retasked within minutes. Hubble followed, locking on to the debris cloud expanding outward from the object's predicted position. Even radio arrays in South Africa and Western Australia began reporting correlated disturbances, faint but synchronized. For the first time since its discovery, 3I Atlas was no longer behaving like a passive interstellar visitor. 48 hours before the event, everything appeared deceptively normal. Orbital solutions showed a clean hyperbolic trajectory. Velocity relative to the Sun remained stable at approximately 43 kilometers per second. Surface temperature, modeled at perihelion distance of 0.82 astronomical units, was expected to rise to roughly 480 Kelvin, well within survivable limits for known cometary bodies. Spectroscopy showed nothing unusual. Water vapor traces were minimal. Carbon monoxide emissions were low. No significant dust coma. No jets. No warning. Then, 11 hours before perihelion, the first anomaly appeared. Tracking stations in Goldstone detected a minor but statistically significant deviation in acceleration, just 0.03 millimeters per second squared. Insignificant on its own, but when Madrid and Canberra confirmed the same deviation, analysts paused. There was no corresponding outgas in force. Solar radiation pressure could not account for it. 6 hours later, thermal imaging from Atacama revealed uneven heating across the object's surface. Instead of the expected gradient, hotter sunward, colder trailing, the distribution appeared patchy, almost segmented. Some regions cooled as others heated, fluctuating by tens of Kelvin in minutes. No known natural process could produce such controlled thermal variance. 2 hours before perihelion, rotational data showed a sudden stabilization. 3I Atlas had been tumbling chaotically since detection. Now, abruptly, its rotation rate slowed and aligned along a single axis. Angular momentum appeared to dissipate without energy loss. Then came the moment that changed the conversation entirely. At 0411 UTC, as 3I Atlas crossed perihelion, instruments recorded a sharp burst of energy. Ultraviolet sensors detected a spike at 160 nanometers. X-ray monitors aboard solar observatories registered a faint but distinct flash, lasting just 0.8 seconds. Optical telescopes observed a rapid expansion of luminous material, an explosion, but unlike any cometary outburst ever seen. The energy release was calculated at approximately 10 to the 12th joules. Too large for trapped volatiles, too small for a collision, perfectly timed, perfectly centered. And then, silence. Radar returns collapsed. For nearly 9 seconds, 3I Atlas vanished from active tracking. When the signal returned, the object was still there, but it was no longer whole. High-resolution imaging revealed fragmentation, not chaotic debris, not a spray of dust, but discrete components, at least 7 major fragments, moving in synchronized trajectories, maintaining relative spacing as they receded. No natural explosion produces formation. Emergency calls were placed within minutes. Dr. Sophia Lindstrom at ESA initiated a Level 3 anomaly response. Dr. Andrew Cole at Caltech ordered immediate N-body simulations feeding in real-time fragment vectors. At MIT, computational physicists began modeling internal stress scenarios. None matched the data. As the hours passed, the mystery deepened. 3 hours after the explosion, spectroscopy detected repeating radio emissions from the fragment cluster. Frequencies centered around 1.42 gigahertz, the hydrogen line. Not narrowband, not a message, but modulated with eerie regularity. Pulse interval 21.3 minutes, then 13 minutes, then 8 minutes. Prime number spacing. This was no longer random, it was responding. Gravitational modeling showed the fragments adjusting their relative positions as if compensating for perturbations. One fragment accelerated by 0.2 kilometers per second, without thrust, without mass loss. Another dimmed in infrared, cooling rapidly against all expectations. At Stanford, machine learning systems trained on millions of cometary and asteroidal events returned a null result. No analog, no precedent. 2 explanations emerged. The first, the mainstream hypothesis, proposed that 3I Atlas was composed of an exotic, metastable material formed in extreme interstellar environments. Under intense solar heating, internal phase transitions could have released stored energy, producing fragmentation and anomalous emissions. Proponents pointed to unknown chemistry, to physics not yet catalogued. But the second hypothesis was far more unsettling. It suggested that the explosion was not a failure, but a function. That 3I Atlas was not merely reacting to perihelion, but using it. That the energy release was controlled, that the fragmentation was intentional. Dr. Marcus Hale of Harvard reportedly stated in a closed session, if this were a human-made system, we would call this a deployment event. Then came the second wave. 17 hours after perihelion, one fragment simply disappeared. Not faded, not drifted out of range. It vanished across all wavelengths, optical, infrared, radio, and radar, simultaneously. No debris, no energy spike, no warning. The remaining fragments reconfigured within minutes, adjusting trajectories to maintain symmetry. Relative spacing stabilized to within meters across thousands of kilometers. At the same time, Earth felt subtle effects. Magnetometers aboard low Earth orbit satellites recorded a brief disturbance, 0.4 nanotesla. Harmless, but synchronized precisely with the fragment pulse interval. Radio blackouts flickered over parts of the South Atlantic. Navigation satellites reported transient timing errors measured in nanoseconds. Inside control rooms, the mood shifted. Encrypted channels lit up. Data releases slowed. Analysts noticed that some datasets were quietly reclassified. World governments were briefed, not on conclusions, but on uncertainty. No one announced panic, but no one dismissed it either. As days passed, emissions from the fragments began to synchronize, pulses aligned, thermal output stabilized. One by one, fragments dimmed, except for a central body that grew brighter, smoother, more defined. It was no longer debris. It was a system. I remember staring at the simulation output as the realization set in. The numbers were calm, the equations balanced, and yet nothing about them felt reassuring. Because for the first time, we were not watching an object break apart. We were watching a process complete. In the quiet that followed, reflection replaced urgency. For centuries, we believed explosions in space were acts of destruction, chaos unleashed by energy. But what if some explosions are acts of creation, of transformation? Maybe 3I Atlas did not explode because it failed. Maybe it exploded because it arrived. As the fragments continue their silent journey away from the sun, instruments remain locked, recording every pulse, every fluctuation, every deviation from expectation. The data keeps coming. The questions keep growing. And one thought refuses to fade. What happens when it does this again? Subscribe to follow the next update, because the story of 3I Atlas is far from over.